Hello, awesome Mindsetters. This is yours truly, Abram himself, on a Women's Month. Yes, it is on a special show also called Learn Extra Live. I'm not alone, I'm with Tracy. Tracy, how are you?
I'm very well, thanks, Abram. How are you?
I'm so good. It gives me a great pleasure and privilege to introduce you as a woman. So I feel like a gentleman, a true gentleman.
Thank you, Abram. I do feel honored. Thank you.
Right. Before I get into details, let me just tell the Mindsetters what the month is all about, and then we'll get to the lesson. Right, Mindsetters, you might be wondering, yes, we always speak about the 9th of August, but what is happening? Now, to just clear the air, on the 9th of August in 1956, 20,000 women staged a march to the new Union Building in Pretoria in a protest against the proposed amendments to the Urban Areas Act of 1950, which is commonly known as pass laws. We might have heard about those. So it's just all about that. We'll be celebrating women, as we say, watinta bafazi, watinta mbogodo. And I'm going to make Tracy to say that and say a shout out to your mom. I'm sure, I think she's watching.
I'm hoping she's watching. Mindset is, I think it's really important that we do honor women because, you know, every great leader has been born from a woman. And the idea is that really it's important to honor our parents always and to specifically honor women this month.
So true. So let's say it together. Watinta bafazi.
Watinta bafazi.
Watinta mbogodo.
Watinta mbogodo.
Simply meaning you strike a woman, you strike a rock. So it is a Women's Month. What are we doing today for everyone?
For everyone. Well, grade 10s, we're going to get them through into mole calculations. And this is the fundamental groundwork that you're going to take forward into grade 11 and grade 12. So grade 12s or grade 11s, if you're out there, you should be watching this too, a very important mole calculations.
All right, as you're about to get into business Mindsetters, you need only 3 things for you to enjoy our lesson. 1, you must log on to Facebook and like our page if you haven't. Our Facebook link is facebook.com/learnextra. Like the page and let's get engaging on the page. Ask some questions. If you have anything that you don't understand, feel free. We have a team of Mindsetters that are there on Facebook to help you. Secondly, you can also follow us on Twitter @learnextra. Follow us and we'll follow you back. Lastly, download the notes for today's session only on learnextra.co.za/live, and they're for free. I'll also post the link on our Facebook page. But for now, let's enjoy the lesson.
Thanks so much, Abram. So, Mindset is we're getting involved in mole calculations. As I said, let's see what we're going to cover today. In this lesson, we're going to be revising the concept of the mole, and we spoke about the mole last week. We want to also discuss volume and concentration in terms of a mole. Then we're going to focus a lot of our time on mole ratios given in a balanced chemical equation. And always we want to solve problems. So I've put here solve problems, and I will specifically also link you to the idea of a molecular and empirical formulae. So we've got quite a lot to get covered. So let's get cracking, get straight into it. Firstly, we want to recap the mole. We spoke last week about a mole as being an amount of substance, almost like a counting unit, like you could count time in days or months or years. We would count the amount of substance in a mole. That is the SI, the standard unit, for amount of substance. We also spoke about Avogadros number, and Avogadros number is 6.022 times 10 to the 23 particles. So if you've got 1 mole of substance, it will contain that number of particles. And that's a very, very, very big number of particles. We have an equation for that where we have N is equal to big N. This N here is the number of particles in my sample, and Na at the bottom is going to be Avogadros number, which I've already agreed with you is this big number, 6,022 times 10 to the 23. And the N at the front is the number of moles. Okay, So you've got how many particles in my sample divided by how many particles in 1 mole will give me how many moles I have, right? The next thing we spoke about in last week's lesson was we spoke about molar mass. And the molar mass is quite a useful concept to have. It is the mass, if I wanted to weigh out in grams the mass of 1 mole, I would work with the molar mass. And so once again, I've got an equation. This one at the top here is going to be the mass of my sample, which is in grams. Okay, the one at the bottom is going to be molar mass, which we worked out from the periodic table. Remember, we took the relative atomic mass for each, or the relative molecular mass for each of the substances, added them together, add them together to give the total molar mass, and that is measured in grams per mole. Okay, grams in 1 mole of the substance, and N is standing for, once again, the number of moles. So we've discussed if I have a certain number of particles, how do I get that to number of moles? Then I've discussed a mass in grams and how to get that to a number of moles. But what happens if I have, say, the volume taking up the volume of a gas in a certain space? You would know it's very hard for us to measure the mass of some kind of gas. Well, because it's going to float very hard to put it on the scale, okay? So very, very hard to on a balance. So we would want to have a different way of working out the number of moles of a gas. And we would work with volume. And then the other thought is, what about if I have a certain amount of substance dissolved to form a solution? Could I also use that to work out the number of moles? And the answer is yes to both of those questions. Come across with me, and we're going to think about these two. If we have volume of a gas, or secondly, if I have the concentration of a solution, can I convert that to moles? Yes, we can. So let's talk about the volume. This volume here is the volume of the sample of gas, and it's measured in decimeters cubed. That unit is very important, decimeters cubed. The next one, Vm, is going to be, this one at the bottom is my molar volume. Do you recall that previously we had the molar mass, the mass of 1 mole of substance? Now I want to have the volume of how much space 1 mole of gas will take up. And this links across to some of the gas laws that you might continue to do, but I want to just mention it to you now, and it is specifically at a specific temperature. So if I was to say, we put this in units, it would be decimeters cubed per mole. Do you recognize that previously we had grams per mole? Now I'm going to have a volume in decimeters cubed per mole. But we need to define this at STP, at a standard temperature and pressure. Because can you imagine, if I was to heat this gas up, the gas will expand and take up more space, and then a larger volume would not necessarily contain the same number of moles. Are you with me? Or if I was to put pressure on it and squeeze, then a smaller volume could contain a greater number of moles. So we define a standard temperature and pressure, okay, STP. Then that molar volume, let's give ourselves some space, that molar volume is equal to a specific number. It is equal to 22.4 decimeters cubed per mole at STP. Okay, we've got that condition. So we would know that any 1 mole of gas will take up 22.4 cubic decimeters of space. Okay, and the N, once again, is standing for my number of moles. Okay. Next we can work across to concentration. So I'm going to give myself a little bit of space and we're going to move across to the side of the board. If I was to dissolve a certain number of moles of substance into a liquid, the solvent, okay, it would dissolve and would make up a certain concentration. Think about this. If you were to put 1 spoon of sugar into some tea or coffee, that would be not significantly concentrated. But if you were to put 2 or 3 spoons, the concentration of the sugar, how sweet it tastes, would be much, much higher. Okay? So the more substances in the same amount of volume would cause a higher concentration. And that's what we would link with this equation here. The C is standing for concentration. Which is going to be moles per decimeter cubed. Now notice I'm saying per decimeter cubed, decimeters to the power of -3. At the top we're going to have here the number of moles, and at the bottom we want to have, let's change to a different color, this V there is the volume of the solvent. That is the liquid that is dissolving this thing. It is also measured in decimeters cubed. Okay, but I want you to notice that volume and this volume of the gas are very different volumes. Here we're speaking about, and I'm going to sketch it here, a beaker with a volume of water in the beaker. Okay, that is the volume that I'm speaking about of the solvent. This one is the volume of space that a gas would take up. Okay, 2 very different volumes. Okay, the volume of a gas versus the volume of a solvent. Right? Let's go across and practice using some of these equations. So, question 1, calculate the number of moles in 6 decimeters cubed of carbon dioxide gas. So immediately I'm thinking, I know this number of moles is equal to volume divided by the molar volume. This question should actually say at STP. Okay, but we'll work with it and I'm going to understand that it's at STP. The volume that I'm given is 6 decimeters cubed. So immediately I'm putting in there 6 decimeters cubed, and I need to divide by the volume of 1 mole of gas, which is at STP 22.4 decimeters cubed. Okay, so let's go to our calculator, clear all of that. 6 divided by 22.4 equals 0.267, so let's round off to 0.27, and we go across here, 0.27, and my unit is going to be moles of CO2. Are you with me? Because that was the gas that I was given and asked to talk about. Right. Can we do one more? Question 2. 5.95 grams. Okay, so immediately I've got that value, and I'm going to write down mass is equal to 5.95 grams of potassium bromide. That is KBr. Go back, K is in group, potassium is in group 1, would donate one valence electron, bromine is in, so bromide would gain that 1 electron, so it's a 1-to-1 ratio. KBr, we've done the formula. Was dissolved in 40 cubic centimeters of water. Now, volume is equal to 400 cubic centimeters of water. Calculate its concentration. So I want to get to the concentration calculation, but I can't just yet. So maybe on the side I'm going to write down this equation, number of moles divided by volume. But before I can do that, I've got to take this mass and convert that to number of moles. You with me? And the second thing I need to watch out for is this volume must be in decimeters cubed. It is currently in cubic centimeters, so I need to do some conversions first. Let's start with that conversion. And I'm going to say, okay, well, the volume is then going to be 400 cubic centimeters divided by 1,000 to get it to decimeters cubed. And we can check that will be 400 divided by 1,000 equals 0.4 decimeters cubed, 0.4 decimeters cubed. Excellent. Let's now go across and work out number of moles, because I've now, if you can go back to this equation, I've done the little volume one, but I now need number of moles. So I've got a second equation in my toolbox that I want us to use, and we're going to start by number of moles is equal to mass over the molar mass. Do you recall that from last time we spoke about the mass of the sample divided by the molar mass? I now have to go work out the molar mass of potassium bromide. You with me? So we've got to go find our periodic table, go find potassium. Let's find it. There it is. On my screen it's 39, bromide. There it is. The molar mass of 80, so 39 and 80. If I go across here, we can write it in. 39 plus 80 is going to give me 39 plus 80, 119. So once again, I've got 119 grams per mole, which means I can now go back and work out the number of moles. So do you recall that would be 119 there? But what was the mass that I had? 5.95 grams was what I had in my sample. 5.95 grams divided by grams, 119 grams per mole. So back to our calculator. Do you understand now why it's called mole calculations? Because you're doing lots and lots of calculations. 5.95 divided by 119 equals 0.05 moles. So what you're imagining, when you're envisaging, is that in this beaker that we have placed, we put in 0.05 moles into a solution which was 0.4 decimeters cubed of liquid, okay, of the solvent. So I can now go and work my final calculation, which is concentration is equal to number of moles divided by volume, because that was what the question was asking. It would be 0.05 divided by, what was that? 0.4 decimeters cubed. Let's go back and check those numbers. We had 0.4 decimeters cubed as the volume and 0.05 moles. So we can come to our final concentration and back to our calculator. 0.05 divided by 0.4 equals 0.12. So back along here, 0.125 I think it is, which you probably could round off if you wanted to. Going back here, or 0.13 moles per decimeter cubed. Okay, that is my final answer. And you've got to go back and check that you've answered the question. Have you told me the concentration? Yes, you have. I think we need to stop and take a short break now. And when we come back, we're going to do one more concentration calculation and then move on to some balanced equations. So, Abram,
on that note, I have some couple of questions which we're going to tackle after the break. But as for you mindsetters, we have a challenging question on our Curio. So if you have your software next to you, go to Curio, which is QURIO.co.za, or Mixit, log on to your Mixit and look for our assessment on Curio, which your code is PS10. So go over there and then check. We have a challenging question right now. You can do it over this break. We'll see you after the break. Now they say, welcome back, mindsetters. Now they say that behind every successful woman, there is a man. But I say behind every great lesson, there is a woman, a great teacher, which is Tracy.
Ah, thanks, Avram. You're so sweet.
Right, let me give you some questions.
Excellent.
Right, the first one, it's from Tami Chire Tusi. It says, what's STP?
What is STP? STP is standard temperature and pressure. And so remember we said that for 1 mole of gas takes up 22.4 cubic decimeters of space. But if I was to increase the temperature, that's not going to be true anymore. If you heat something, usually it expands. So the idea is we've got to define a standard temperature and pressure that we can then say, all right, then 1 mole of gas will take up 22.4 cubic decimeters. So it's the standard conditions under which 1 mole of gas will take up that amount of space.
All right, and for question 1, how did you get the 22.4?
Okay, the 22.4 cubic decimeters is the standard volume that 1 mole of gas takes up at 22.4. It's on your data sheet. You can go and work with it. It's there for you.
All right.
Okay. Excellent. So, mindsetters, let's take it away with another question. I think I'm jumping one. There we are. Question 3. What mass of hydrogen chloride is needed to make up 500 cubic centimeters? Now, I saw on the page there was one other query about this cubic centimeters. Be very cautious in terms of converting, all right? 500 cubic centimeters we have to get to a cubic decimeter value. So, and when you're going from cubic centimeters to cubic decimeters, you have to divide by 1,000, right? Go back. Sorry, let's just undo that. You've got to divide by 1,000. Go back and work on your converting, all right? The idea is that because this is in 3 dimensions, you've got to convert it 3 times, which is why you've got to divide by 1,000. So I'm going to divide that by 1,000 to get it to decimeters cubed, which is then going to be 0.5 decimeters cubed. Okay, and we can go across there and just 100% check it. 500 divided by 1,000 equals 0.2, which is 0.5. Perfect. Okay, what mass of hydrogen chloride is needed to make up that volume of a solution of a concentration? So this question, they're going to give us the concentration. 1 mole per decimeter cubed. Okay? And my question is, the question is asking me, what mass of HCl, okay, must I add in to make up a concentration of this? All right? Now, what we need to do is start with our concentration calculation, and what we're going to work out is work out number of moles, and once we've gotten to number of moles, we're going to work back through the molar mass to get the mass. Are you following the logic? So I'm going to use concentration is equal to number of moles divided by volume. Once I've done that, I'm going to use a second equation. Number of moles is equal to mass over molar mass. Okay, so there's 2 sets of things we've got to get through in this question. Let's start with the concentration bit. And I want to rearrange this equation first. I want to find number of moles. So I'm leaving N that side, and it's going to be C multiplied by V. So the concentration is 1, and I'm multiplying it by the volume, which I converted into cubic decimeters as 0.5, and that will be equal to N. So N is equal to 0.5, because 1 multiplied by 0.5 5 will give me 0.5, and it's moles, okay, of HCl. Now the second part of this question, I said to you, we're going to need to work number of moles is mass over molar mass. And here I'm going to try and solve for the mass. But first I need to find the molar mass. So, second part of the question. The molar mass of HCl. Go back, let's check that it was HCl, hydrogen chloride, and they gave us the formula, so I can come back down here and let's go across, find the values. H is 1, Cl is 35.5, so when I come across here, it's equal 1 plus 35.5. Remember, mindset is you need to use the data sheet that you've been given because you want to be as accurate as possible in terms of getting those values. Is equal to, well, it will be 36.5. Are we all in agreement? Grams for every mole, so grams per mole. Now I can come across to the last part of this question and work out number of moles is equal to mass divided by molar mass. And remember we said, okay, I want to find mass by itself. So I'm taking the molar mass to the other side, the number of moles multiplied by the molar mass. I just switched them around, but taking molar mass to the other side, it was dividing, it will now be multiplying. So we've got those. I now have 0.5 moles of HCl, hydrogen chloride. So that's my one substitution, 0.5 multiplied by 36.5 grams in every mole, grams per mole. So going across to our calculator, 0.5 multiplied by 36.5 is equal to 18.25. So my final answer here, 18.25 grams of HCl. Now you might ask me, why do I keep writing out what I'm dealing with? Well, for the very reason that I don't want to get confused. Because you'll notice in the next segment of what I'm going to talk about is whole full equations. So it's very important that you make sure that you're explaining what you're dealing with. We're talking 18.25 grams of HCl, and it will just help to clarify for you what you're dealing with. Excellent. Come across with me now as we start to talk about balanced equations. And a balanced equation is a very, very important idea. In a balanced chemical equation, and it has to be balanced. If it's not balanced, all your mole calculations are not going to work. So make sure you know how to balance things if you first are asked to balance the equation. The number in front, okay, so when I say the number in front, I'm talking the big number in front. So maybe it's 2H2O. I'm speaking about this big number in front, okay? Describes the mole ratio of the reactants and the products. And what it is allowing us to do is then compare the number of moles of either reactants to reactants or reactants to products or products to products. It's going to allow us to compare using number of moles. All right? So you have to start with a balanced equation, number one. Then what I want to recommend to you is, because you can now compare with a mole ratio, you have to then convert whatever you've got into moles. And you've got a number of particles that you could use Avogadros numbers to get to moles. You've got mass you could get to moles. You've got volume that you could get to moles. Or you've got concentration that you could get to moles. So you've got 4 equations at your disposal. And I've got a quick schematic little spider diagram here, if you like. But I want you to encourage you to always take the mole route. Almost like a little, you know, those little scurrying moles that burrow underground and then go underground and then pop up somewhere else. Okay, the same kind of idea. Convert to moles. Then you can do a mole comparison mole ratio, and when you come out the other side, you would then be able to answer whatever the question is. So take the mole root. So I'm highlighting here. We've got mass. You've got the equation. N is equal to mass over molar mass. The next one, concentration. We've done concentration is number of moles over volume. Or volume, you can convert to moles. Then you've got a ratio that you can compare number of moles to number of moles. And then from there, you can answer whatever question they're asking you to take you to mass, or to take you to concentration, or to take you to volume, or particles for that matter. Okay? Once you've got a mole ratio, you can do anything. Right? Let's try one of these questions and see how this is going to work out. Question 4 and 5 are very, very helpful. So make sure you're following with me. Calcium chloride reacts with carbonic acid to produce calcium carbonate and hydrochloric acid. Please, don't lose me along the way. They're giving us the equation. You're not going to get lost. So we start off with calcium chloride. That is this stuff. Okay? 1 calcium to 2 chlorides. Reacts with carbonic acid. I know it's going to have H's and the CO3 in it. Okay? To produce calcium carbonate. Let's change color and do calcium carbonate in blue. The calcium with the carbonate polyatomic ion and hydrochloric acid. HCl. There's the HCl. Okay? So actually you've got it all in the equation. According to the following equation, if you want to produce 10 grams of calcium carbonate, so I'm highlighting this bit in blue to indicate to you I want 10 grams of that stuff, calcium carbonate, at the end. Through this chemical reaction, what quantity in grams of calcium chloride would you need at the start of the reaction? So they're saying to us, how much of this stuff must I put in at the start? Okay? How much calcium chloride do we need at the start? So, big tricky problem. It's not that bad. Let's do it step by step. What I would recommend that you do whenever you come across big things like this is to start by writing the equation again. Now I know you might say, oh, but it sounds like a waste of time. I promise you it won't be. So let's have it there, and we'll write calcium chloride plus H2CO3 forms calcium carbonate plus 2HCl. If you start with that, check that it's balanced. 1 calcium, 2 chlorides, 2 multiplied by 1, which is 2 chlorides, 2 hydrogens, and the carbonate all fine, fabulous. It's balanced. Now I want us to recommend that we put the information down. We said we wanted to end up with a mass, sorry, let's just undo that. My mass here of 10 grams. So that was for the calcium carbonate. So I'm going to work with calcium carbonate, work out how many moles that must be. How do I do that? Well, I need to work out the molar mass of calcium carbonate. So I need a periodic table. Sorry, let's go down here. Give ourselves some space. I need my periodic table. Let's go and find calcium would be 40. Carbon is 12. Oxygen is 16. Go back to my question. Calcium was 40 plus carbon, which was 12, plus 3 times the oxygen, which was each 16. Okay, so do you recognize that I've got all of those components, the mass of each of them, and I need to work out what they each are. So let's go across to our calculator. I'm going to start at the end. So 3 times 16 is equal to 48. To that 48, I'm adding 12, and I'm adding the 40. And that's equal to 100 grams in 1 mole. So going across here, this is 100 grams per mole. Are you with me? From that 100 grams per mole, I can now say, all right, what is the number of moles? It is the mass divided by the molar mass. Recognize that I'm converting mass to number of moles. That mass is equal to 10 divided by 100. Why? Because I was asked to make 10, and I know that each one is 100, so this should be 0.1 moles of calcium carbonate is what I want at the end of this reaction. Okay? Notice I'm asking you to write the formula of what you're dealing with each time. From there, I want to now compare number of moles. So I want to go up to this original equation again, and I'm looking here and saying there is no number in front there, and there is no number in front there. So my mole ratio, and this is the next step that I'm comparing, I've got a mole ratio. That ratio was a 1:1 ratio. Do you recognize that there was an understood 1 in front and an understood 1 in front? Like we don't write 1x, we just write x. Okay? It's not there, so it's understood to be 1. Which means that surely if it's a 1:1 ratio, then this would be 0.1 is to 0.1 moles of each of those two. Which means that I must start with, therefore, 0.1 moles of the calcium chloride. Do you see how I've taken that big leap by converting to moles, comparing the mole ratio, and now I know that if I ended up with 0.1 moles of calcium carbonate, I must have begun with 0.1 moles of calcium chloride because of that 1:1 ratio. So, heading back here, I now can answer my question. Because I think I was asked to work out the mass, check it, yes. I think that was a huge leap. So what we're going to do is take a short break now, and when we come back, we're going to do 2 more questions like this. So mindset is, take a short break. Abraham.
All right, still mindsetters, you can still take a challenge on our Curio. Visit curio.co.za via your Mixit. Also, you can join Curio and take some assessment, and let's see if you understand the lesson and where you're struggling. Remember, the code is PS10. Don't move. We'll see you after the break. Welcome back, awesome mindsetters. This is still your favorite show ever, the best learning show ever on Physical Sciences Grade 10, Learn Extra Live with AB and Tracy.
Thanks, Abraham. And mindsetters, I'm hearing that a lot of you are getting on and working on those Curio questions. I'm hearing from my producer that you are working on question 1, and that the answer that a lot of you are saying is incorrect. The answer is actually A, all right? Because go back and read the question again, where they're asking for atoms. If they're asking for atoms, then you need to not just say the total number of particles, but you need to multiply to get to the number of atoms. Right, so go back and check those. Let's come back to this question that we were working on. The question asked us specifically to calculate the mass of calcium chloride that we would need if we wanted to end up with 10 grams of calcium carbonate. So we worked out, all right, well, 10 grams of calcium carbonate, we worked it through, and we worked out, I'm just doing a bit of a strategy session here with you. We worked out, let's work the strategy in green. We worked a mass, and we converted the mass to moles. Once you've got it in moles, you want to compare, and let's go down here, a mole ratio. So the number of moles of the one substance compared to the other substance. And so we had our mole ratio. And from a mole ratio, we now have the number of moles of the second substance. And now I'm going to work out the moles to work out the mass, which was the question at the start. Right? So do you recognize the strategy? Take the mole root, convert to number of moles, compare the mole ratio, and you can get your final answer. So 0.1 moles of calcium chloride is what I must have started with. So I now have number of moles is equal to mass over molar mass. And I think I need to go and work out the molar mass of the substance. So on the side here, molar mass of, what is it? Calcium chloride. Now I recall that calcium was 40, but again you're going to check on your periodic table, and we're multiplying 2 times 35.5. So let's just quickly check those. Sorry, the periodic table. We had 35.5 and 40. Okay, so going across here again, I want a calculator. 2 multiplied by 35.5 is equal to 71. To that I must add the 40. Do you notice how I always do the multiplication first? Because that is a good safeguard for me, that I check that I have multiplied by the number of the number there. So 101 grams in every mole of calcium chloride. Going across now to my equation, number of moles is equal to mass over molar mass. I want to find what the mass is. That's what I want by itself. Okay, so number of moles multiplied by molar mass is equal to the mass. And I want to find out what that mass is. So we've got 0.1 moles of calcium chloride. That's what I'm putting in, 0.1 multiplied by 101, which was the molar mass. Okay? So, back to our trusted calculator, 0.1 multiplied by 101 equals 11.1, and my unit here, 11.1, must be grams, because this is the mass of calcium, sorry, let's undo, of calcium chloride that I must put in at the start. So mindset is follow the strategy. You're going converting mass to number of moles, and from number of moles you can compare the mole ratio and then convert the moles to the mass again. Let's try a more challenging question on the same idea. This next question, question 5. Sodium azide is a commonly used compound in airbags. You know, an airbag, a person's driving a car, they have a car crash, poof, the airbag bursts and opens up, and it slows the person down, and so they don't get injured. When triggered, it has the following reaction. So this amount is a solid, and when it reacts to form another solid, but specifically a gas, and that gas would fill up the space of the airbag. If 23.4 grams of sodium azide, which is the NaN3, is used, then how many moles of nitrogen gas would we expect to produce? So we're working with the nitrogen, which is that stuff as well. And then what volume would this nitrogen gas occupy at standard temperature and pressure? So once again, I'm always going to start by writing down the equation that they've given me and checking that it's balanced. So 2 Na sodium N3 forms 2Na plus 3N2. And I'm going to write down immediately that I'm working with a mass here of 23.4 grams. The 23.4 grams is the mass that I'm starting with. Now, I want you to notice here that we're going to convert, follow the plan of action, okay? Although, yes, I have been given values to, questions, sub-questions, I've got a general plan. I've got to convert mass, first and foremost, to moles. Once I've got that moles, I'm going to use the mole ratio to work out the moles of the nitrogen. Okay? Once I've got the moles of nitrogen, I want to convert to what that would be as a volume at standard temperature and pressure. So you're following that I've got, it looks like a big crazy sum. It's not that bad. I've got a plan. I can convert mass to moles. Done lots of that. I can then convert moles to moles, comparing the mole ratio, and then I can convert moles to volume. Let's get straight into it. So, next I need to have the molar mass of NaN3. That's the sodium azide. Notice here for me quickly that I'm leaving that big 2 out of this molar mass calculation. The molar mass is the mass of 1 mole of gas or of any substance. So that big 2 in the front is the mole ratio. I'm not using that. Okay, that's one of the biggest errors that students do have. So let's go across. We're going to have to go to our periodic table, go and find those values. Sodium is there, 23. Nitrogen is over here, 14. I think that's all we need. Let's go across. So this was 23 plus 3, 23 plus 3 times 14. Check those values. 23 and 14, and we're good. Again, I'm going to start with the 3 multiplied by 14 equals, and to that I'm adding the 23 for the sodium. So 65 grams per mole of that substance. So 65 grams per mole of the sodium azide. Now my next thought was convert to number of moles. So number of moles is equal to mass over molar mass. And what did I have? I had 23.4, but I'm dividing that by the 65. Okay, so 23.4 divided by 65 equals 0.36. 0.36 moles of NaN3. Okay, so I've done my first half of this question. When I say I've done it, I've done this first little loop. I've converted the mass to the number of moles. Now the next part of the question is where it does get quite tricky. I'm now wanting to take the mole root. And I've circled those 2 numbers because I want you to identify that we're taking the mole ratio. And remember, we were dealing with NaN3 is to N2. So, going back to the equation, it was 2 is to 3. So, we've got to write that. Well, 2 is to 3. That 2 is to 3 ratio is what is the ratio that I'm going to have to be using. So, if I work with then 0.36 is to question mark. How am I going to get there? Well, first I want to divide by 2 and then multiply by 3 to go across that ratio sign. So 0.36, it's there, divide by 2 is 0.18, but I need to multiply that by 3, and that's going to get me to 0.54. So back to my equation here, and I'm going to change the color so you recognize that I've worked this one out. Okay, that was 0.54. The idea is we went back to the original equation and said there is a mole ratio between these. Because it's a balanced equation, I can compare the number of moles. And you can check its balance. 2 sodiums is just 2 sodiums, 6 nitrogen, 3 multiplied by 2 is equal to 6 nitrogen. I can now compare the mole ratio, and it will tell me if I've got 2 moles of the sodium azide, it must form 3 moles of the nitrogen. So therefore 0.36 must form 0.54 moles of the nitrogen. And that's solving the first part of this equation, of this question. From that, mindset is you can go and work out the volume, which was part 2 of this question. And I think that's all the time we have left. The idea behind this is that you are literally looking at that mole ratio and working out, solving the information from what you have. So use that balanced equation to work with the number of moles, and you can take the mole root to solve anything. I really hope that that has helped you and that all these mole calculations will go brilliantly for you. That's me signing off for now. Keep well, God bless, and study hard.
Thank you so much, Tracy, and to you, happy Women's Month.
Thank you so much.
Right, Mindsetters, that's all we have for you, grade 10s. But otherwise, we had a great lesson. I hope you've learned a lot. Give us your feedback on Facebook. And if you're still struggling, feel free also to visit our Facebook page, which is facebook.com/learnextra. And you know what? Well done to Apiu and Morgan Makatini, our Mindsetter of the Month. He got 4 out of 5 questions. Yeah, well done on our QO assessment. Otherwise, thank you very much, Mindsetters. We'll see you some other time. Peace.
In terms of a mole. Then we're going to focus a lot of our time on mole ratios given in a balanced chemical equation. And always we want to solve problems. So I've put here solve problems, and I will specifically also link you to the idea of a molecular and empirical formulae. So we've got quite a lot to get covered. So let's get cracking, get straight into it. Firstly, we want to recap the mole. We spoke last week about a mole as being an amount of substance, almost like a counting unit, like you could count time in days or months or years. We would count the amount of substance in a mole. That is the SI, the standard unit for amount of substance. We also spoke about Avogadros number, and Avogadros number is 6.022 times 10 to the 23 particles.
It's the proposed amendments to the Urban Areas Act of 1950, which is commonly known as pass laws. We might have heard about those. So it's just all about that. We'll be celebrating women as we say, Watinta Bafazi, Watinta Mbogote. And I'm going to make Tracy to say that and say a shout out to your mom. I'm sure, I think she's watching.
I'm hoping she's watching. Mindset is, I think it's really important that we do honor women, because you know every great leader has been born from a woman, and the idea is that really it's important to honor our parents always, and to specifically honor women this month.
So true. So let's say it together. Watinta Bafazi.
Watinta Bafazi.
Watinta Mbogoto.
Watinta Mbogoto.
Simply meaning you strike a woman, you strike a rock. So it is a Women's Month. What are we doing today for everyone?
For everyone. Well, grade 10s, we're going to get into mole calculations. And this is the fundamental groundwork that you're going to take forward into grade 11 and grade 12. So grade 12s or grade 11s, if you're out there, you should be watching this too. A very important mole calculations.
All right, as you're about to get into business mindsetters, you need only 3 things for you to enjoy our lesson. 1, you must log on to Facebook and like our page if you haven't. Our Facebook link is facebook.com/learnextra. Like the page and let's get engaging on the page. Ask some questions. If you have anything that you don't understand, feel free. We have a team of mindsetters that are there on Facebook to help you. Secondly, you can also follow us on Twitter @learnextra. Follow us and we'll follow you back. Lastly, download the notes for today's session only on learnextra.co.za/live, and they're for free. I'll also post the link on our Facebook page. But for now, let's enjoy the lesson.
Thanks so much, Abram. So, mindset is we're getting involved in mole calculations. As I said, let's see what we're going to cover today. In this lesson, we're going to be revising the concept of the mole, and we spoke about the mole last week. We want to also discuss volume and concentration. So, if you've got 1 mole of substance, it will contain that number of particles, and that's a very, very, very big number of particles. We have an equation for that, where we have N is equal to big N. This N here is the number of particles in my sample, and Na at the bottom is going to be Avogadros number, which I've already agreed with you is this big number, 6,022 times 10 to the 23. And the N at the front is the number of
Hello, awesome mindsetters. This is yours truly, Abram himself, on a Women's Month. Yes, it is on a special show also called Learn Extra Live. I'm not alone. I'm with Tracy. Tracy, how are you?
I'm very well, thanks, Abram. How are you?
I'm so good. It gives me a great pleasure and privilege to introduce you as a woman. So I feel like a gentleman, a true gentleman.
Thank you, Abram. I do feel honored. Thank you.
Right. Before I get into details, let me just tell the mindsetters what the month is all about, and then we'll get to the lesson. Right, mindsetters, you might be wondering, yes, we always speak about the 9th of August, but what is happening? Now, to just clear the air, on the 9th of August in 1956, 20,000 women staged a march to the Union Building in Pretoria in a protest against